Modern labs are filled with cutting-edge devices, generating vast amounts of data. But this technical power is undermined by fragmentation. Devices don't talk to each other, and data lives in silos. And most workflows rely on fragile manual steps that belong to another era. Making these systems work together means writing scripts, connecting APIs, automating processes. But the people closest to the lab work usually can't do that. Not because they don't want to, but because they are not programmers. And that disconnect, it slows everything down and making research far less efficient than it could be.
Hi, I'm Julian Kimmig, CEO and co-founder of Linkdlab. Before we started building software, my co-founders and I worked in labs as chemists and physicists. At one point, we were running high-throughput experiments, but with almost no automation at hand. We had a clear scientific goal, but we realized we'd spend months or even years just collecting and analyzing the data manually. So we built a basic automation tool just for ourselves, and it worked. Soon, others started asking for it too, and that's when we realized this wasn't just our problem. Scientists everywhere have the hardware and the data, but not the tools to connect them. And most labs don't have time, resources, or staff to build it themselves. And that's why we started Linkdlab, to close this gap between devices, data, and decisions, and give scientists the power to automate their own workflows without needing to write any code.
In most labs today, the real bottleneck isn't the science, it's the process. Instruments come from different manufacturers. Each has its own software, file formats, and communication quirks. They don't connect and they don't coordinate. So scientists end up doing everything manually, transferring data, reformatting spreadsheets, copying values between systems. And if you do have automation, it usually is dedicated hardware for a specific task. But the overall research and development process requires hardware automation, automatic evaluation of the results, and a feedback loop back to the hardware, learning from previous results. And missing out this local small size end-to-end automation comes with a cost: wasted time, missed insights, and slower innovation. So, what should a modern lab platform actually look like? First, it has to be accessible. Scientists should be able to build and run workflows without writing code. It needs to be modular and reusable, so teams can set up once and adapt across projects. Especially in R&D departments, the task changes regularly, and so should the automation, without the need to require external services every time or a reprogrammation of the whole system. It must connect to instruments, data systems, and cloud tools seamlessly. And it has to work in real time, reacting to data as it arrives, adjusting parameters, closing feedback loops. Whether it's on a laptop or a distributed network, the system should scale as your lab grows. And behind the scene, it should still allow full control and customization for developers. And finally, it needs to be transparent and reproducible. And that's what we are building. We founded Linkdlab to meet those exact needs. One of the cores of our services is a self-developed framework called Funcnodes. It lets scientists create complex automated workflows, but not with code, but with a visual drag-and-drop interface. Each step in your process becomes a node. One node reads data, another one analyzes it, and another one controls the device. You connect these nodes like a flowchart, intuitively, transparently, and in real time. And because it's modular, you can reuse and adapt workflows across teams, projects, or even institutions. For scientists, it means building automation without needing IT. And our core framework is even open source, so it can be easily extended by developers to integrate existing in-house solutions or custom functions. It's a platform designed for the lab and for the people working in it. Our framework is built around a clean, scalable architecture with 4 key components. Behind the scenes is the Funcnodes core engine, an event-driven asynchronous system that ensures each node runs as soon as new data is generated. Execution is handled by a distributed worker system. Each worker runs independently, which means you can scale across multiple processes, machines, or even locations, locally or in the cloud. The interaction happens via a visual front-end, a browser-based interface where you build and monitor workflows in real time. It's intuitive, flexible, and fully no-code. And the actual functionalities are distributed in modular node libraries, reusable building blocks bundled by task or research field, individually installable, allowing each workflow staying as lightweight as possible and as powerful as required. Whether you're running a simple flow for data analytics or orchestrating a complex experimental loop, Linkdlab makes it possible.
Let's now have a look at some real examples. So for example, what you can do is you can perform interactive design of experiments. Basically, you just create your design space of your experiments, whatever your input variables are, whatever your outputs are. It can be categorical, it can be continuous, whatever it is. You can define multiple optimization targets, and then you get a model which basically provides you with the next iteration step. So it recommends you the next idea. And what is really nice, that you can also have a look into the model. So you can basically see what the model makes its decision based on. So you can see the internal model of the design space that is created by the model. Another example would be to have dynamic evaluation of SEC HPLC data. And the really nice thing is that you can also perform peak deconvolution, meaning can just integrate the signals and get the normal results, but you can also fit the signals and get some nice results of overlapping peaks, overlapping data, and evaluate them individually. Another example that is really nice to have, and I would really like to show you, is structure property relationship prediction. So there are a lot of models out there which are hidden behind the code wall, and basically with our tool you can just use them as a single node. So you feed them your CSV data, you train it, and you get the trained model out there. You can see all the training statistics. You can then interfere it with new data, so you can directly ask it structures, as in this input here, but you can also of course connect the database to it. And the final example I give you now is you can also of course perform image analysis, which is really useful, for example, for microscopic data. In this case, you can see that we have developed a tool that easily performs particle detection. So you get really like all the particles are detected immediately, and you get all the results, all the intrinsic parameters of the individual particles as a table. You can of course download it, but what you can also do is process it further, and you get like the statistical distribution of the particle size.
Across all these examples, the impact is the same: faster results, fewer errors, and workflows that anyone on the team can use, adapt, and repeat. At Linkdlab, we didn't start as a software company. We started as scientists with real experiments, real deadlines, and real bottlenecks. That's why everything we build is focused on what actually works in the lab. It has to be fast, flexible, and easy to understand. We made our framework open source because we believe in scientific infrastructure that is shared, not siloed. Automation should be available to everyone, not just the team with the biggest IT departments. And we are not alone in the belief. A growing community is already building and sharing node libraries for chemistry, biology, material science, and analytics. When we lower the barriers to lab automation, we don't just save time, we unlock entirely new ways to do science. And so, our mission is pretty simple: to bridge the gap between devices, data, and decisions, and give scientists the power to work smarter, faster, and more reproducible. So if you're ready and want to try it out yourself, to start building your own workflows and see how much faster and easier your lab work can be, don't hesitate and contact us. You can also check out one of our webinars where we dive deeper and where we show real use cases and live demos. We are looking forward to hear from you.